Welcome back to Robominions.in AI interview preparation app. The topic of this video is creating binary search tree using insert. So this is the code we have for creating a binary search tree. Before tracing the code, I request you to watch this video on a laptop or a full screen on the mobile phone so that the code is clearly visible. If it is not visible on your phone, I strongly suggest you to watch it on a laptop so that you can trace the code along with me. There is no tracing, this kind of tracing software available anywhere else on any of the YouTube channel. I can assure you that. So this is the only YouTube channel which is giving such an opportunity for you to trace along with the developer. And also download the Robominions.in AI interview preparation app. So this app, once you watch the video, you have a clear understanding of the concepts. But after a month or two, you tend to forget those concepts, and every time to revise, you have to watch the video. But instead of that, we have a easy chance to just click back and next button and control the code and see the execution of the code and see the output. So you have a graphical interface here, then the code tracing happens here. So you have a clear visualization of the code. So go to website robominions.in, download the latest version of the app here, and if you have a Windows laptop, download for Windows OS, and then click on download anyway. Yeah, coming back to creating binary search tree using insert. So when I click next, we have this arrow. So don't forget to trace the arrow. So this arrow will go to the execution line of the code. So right now we have hash include stdio.h, then we have hash include stdlib.h. Then we have type def struct node. The struct node has been renamed with node. In the structure of this struct node, we have left child node pointer, then we have data member variable, and then we have right child node pointer. Node pointer. And the convention we follow is here. It has a left child, data value, right child, and a node address at the bottom. Then we have node pointer root equal to null. Then we have a function insert to BST of key. So this function is declared. So this will be used to insert key to the binary search tree. Then we go to int main. We have insert to BST of 11. Data 11 is key 11 is inserted. So void. Then we have declared t underscore ptr pointer, which is assigned with the root value. Right now the root is null. Then we have two more pointers, r underscore ptr pointer, new node underscore ptr pointer. Now right now root equal to null is true. So we have new node pointer equal to memory is allocated. You can see with the garbage value and hash 100 memory address. Now we assign the data here. Now key is 11. 11 has been assigned. Left child equal to null. Right child equal to null. And then root equal to new node ptr pointer. So root is now pointing to this node. Then we return from the insert to BST function. So we have gone back. Now we insert the second key. Insert 9. So goes to insert to BST. Now t underscore ptr equal to root. So now this pointer is pointing to the root. Another two pointers are created, rptr pointer, new node pointer. Now if root equal to null is false, because root now is a valid node, so it is not null. So it goes to the while t underscore ptr not equal to null. Yeah, it is not equal to null. It is pointing to a valid node. It goes inside the while loop. Now rptr equal to tptr. So both r and tptr are pointing to the same node. Now we have if key is less than t underscore ptr data. Key right now is 9. 9 is passed to the insert function. So 9 is less than 11 is true. Yeah, it is true. So it goes inside the if condition. So tptr is equal to t underscore ptr of left child. So tptr is equal to, so tptr of left child was null. So null is assigned. Then it goes down and checks the while condition again. This time t underscore ptr not equal to null is false, because t ptr was assigned with left child of this node, because the previously t ptr was pointing to this node. So t ptr equal to t ptr of left child is left was null, right? Okay, so now we are, I hope you're clear. Comes out of the while loop, a new node is created, a memory is allocated with the size of node in the heap. So we see a new node is created, data is added with the key 9, and new node ptr left child equal to null, new node ptr right child equal to null. Okay, now again a key is checked, key is less than rptr data. Rptr is right now pointing to this node. Key 9 less than 11 is true, it goes inside the if condition. Now rptr left child is equal to new node ptr. So rptr is pointing to this, right? So rptr left child is equal to new node's new node pointer address is hash 200. Hash 200 is assigned here, you can see. So then it comes out of the function insert to BST. So we have successfully inserted 9 on the left side of the binary search tree. So left side of the root in the binary search tree. Then we insert 22. So next we have 22 data, that is the key. So insert to BST 22. So again t underscore ptr equal to root. So now it is again pointing to the root, creating two new pointers, rptr and a new node ptr. Right now root equal to null is false, root is not equal to null. Goes to the while, t underscore ptr not equal to null. Yes, t underscore ptr is not equal to null. Right now it's pointing to this node. R underscore ptr is equal to t underscore ptr. Both rptr and tptr are pointing to both the pointers are pointing to the same node. Now key is checked. If key 22 is less than tptr data, tptr data is 11, 22 less than 11, false, goes to the else if part. Key 22 greater than tptr data 22 greater than 11, yeah, that is true, it goes inside the else if condition. Now tptr is equal to tptr of right child. So right child is null. Tptr, I'm going back, I'll click back, you can see. So just a reminder, see how I clicked back and you got the previous step again. So you went to the previous step. So that is the beauty of this app. So whichever step you get somewhere stuck, you can just click a back and you go to the previous execution step, and then again you click next, you get back the execution. So anytime, how much ever step you want, you can go back. Okay, so that is the beauty of this app, you can trace any way you want. So now right now you see tptr is pointing to the node with the data 11. So tptr's right child is null. So tptr's right child will be null. So when I click next, now tptr equal to right child will be null, will be assigned to tptr. Okay. So when the while condition we go back, now right now tptr is null. So this condition tptr not equal to null become false. Comes out of the while, a new node is created now again. So memory is allocated, new node ptr is pointing to this new memory location. It has address hash 300. The data key is added, new node data equal to 22. Key is 22, right? We sent that is what is we sent in the to this function. Left child null, right child null. Both are null. Then we check key less than rptr is still pointing to the root. So key is 22 less than 11, false, goes to the else part, and then rptr right child equal to new node ptr. So rptr's right child, that is this one, equal to this node. So this node is address is hash 300. Hash 300 is assigned to right child pointer. You can see we have clearly added the key 22 to right side because 22 is greater than 11. So in binary search tree, we compare the data with the root. If it is smaller, we put it in the left side. If it is bigger than the data, we put it in the right side. So that is the convention we follow in the binary search tree. So we have successfully added 22. Now end of the insert to BST. Now we insert 18 to the binary search tree. When we insert to binary search tree, the key now is 18. Again, a TPTR pointer is created, which is pointing to the root. Okay. RPTR is created, new node PTR is created. Now, if root equal to null, root is not equal to null, it is a valid node. So this is false. It comes to the while condition. TPTR not equal to null is true. TPTR is not equal to null, it is true. It goes inside the while loop. RPTR equal to TPTR. So both are pointing to the same node. Okay. Now if key is less than, now key is 18. 18 is 18 less than TPTR data. TPTR data is 11. 18 less than 11 is false. 18 greater than 11 is true. It goes inside the, 18 is bigger than 11, right? It goes to the right child. So TPTR equal to TPTR of right child. So now TPTR pointer is pointing to the right child. So end of the while iteration. Now again a while condition is checked. Is in the while condition, it checks whether TPTR pointer is not equal to null. Yeah, it is not equal to null because it is pointing to a valid node. That is true. So it goes inside the while condition. Now RPTR equal to TPTR. So RPTR, from here it started pointing here because it has been reassigned with the TPTR. Now again the key is, remember key is 18. Now key data is checked with this node. 18 less than 22 is true. 18 less than 22. So it comes in the left side. So TPTR equal to TPTR of left child. Left child is TP. So by just clicking back, you can see TPTR is pointing to this node, right? TPTR of left child is null. Remember, TPTR of left child is null. So when I click next, TPTR of left child null is equal to, so it is been assigned to TPTR. So T underscore PTR is equal to now null. Hope it's clear. End of the while condition. Checks the while condition again. Now you see TPTR null not equal to null is false because both are equal. You can see T underscore PTR is null. Null not equal to null is false. Comes out of the while condition. Now again a new node PTR pointer is allocated memory. So when I click next, it has been allocated, new node PTR is allocated a memory at location hash 600 with a garbage value. Now data 18 is assigned. So you can see data is equal to key. The data is assigned with key 18. So 18 has been assigned. So left child is made null. Right child is made null. So new node is clearly assigned. Then we see key 18 less than RPTR data. So RPTR right now is pointing to this node, that is 22. So 18 is compared with 22. 18 less than 22 is true. So we have to link this, right? You have to make a connection. So when I click next, that connection is established by R underscore PTR left child of RPTR is this, equal to new node PTR. So new node PTR address is hash 600. So this hash 600 address will be copied to this location. So when I click next, you see hash 600 has been assigned and the arrow, the link has been established successfully. 18 is less than 22. That is why it is been linked in the left side of the binary search tree to the node 22. It has been assigned to left side. Successfully inserted 18. Done with the insert to BST function. Now we have insert to BST 40. Now key is 40. So let's see. Insert to BST is called again. Now key is 40. t underscore ptr equal to root. Again, we have successfully found, we have assigned the root here, created two more pointers, that is same, rptr new node ptr. If root equal to null, false, root is not equal to null, comes out of the if doesn't go inside the if condition, checks the while, tptr not equal to null, yeah, tptr is pointing to this node, it is not equal to null, it goes inside the while condition, rptr equal to tptr, both are pointing to the same node. Then key 40 is checked with the tptr data. So right now the tptr data is 11, 40 less than 11 is false, comes to the else if 40 greater than tptr data, 40 is greater than 11 is true. Now tptr's right child is assigned to tptr, so tptr equal to tptr's right child, so hash 300 is been assigned to tptr, so it will the pointer is pointing to this node. Now hash 300 is this node. Again, end of the while condition. Now again it checks whether tptr not equal to null, that is true, tptr is pointing to this node, it is not equal to null. rptr equal to tptr, so rptr which was pointing here has come down now because rptr equal to tptr. Now both pointers are pointing to the same node. Now again 40 key is checked with the tptr data, 40 less than 22 false, comes to the else if part, 40 greater than 22 true. Now again tptr pointer equal to tptr of right child, so right child is null, tptr's right child is null. So if when I click next, see, you can see tptr equal to null. So when it checks the while condition, now it fails because in the condition we have tptr not equal to null, comes out of the while condition. Now new node ptr is pointer is allocated memory. So when I click next, it's allocated memory here, new node ptr. Now again data is 40 is assigned to this node. New node left child is null. Now right child is null. Now key 40 less than rptr data. rptr data is still rptr is still pointing to the parent node of it's pointing to the parent node, right? Still is still pointing to this node. That is data is 22. 40 is less than 22, false. 40 is greater than 22, so 40 has to be in the right side. So it goes to the else part and rptr's right child is assigned hash 700. That is the address, right? Hash 700 is the address that has to be assigned here so that the link is established. When I click next, you see hash 700 has been assigned and we have successfully inserted the node with the data 40 to the right side of this node. Insertion is done, comes out of the insert to bst function. So we have successfully created the binary search tree. We have one more key which has to be inserted, that is 8. So let's try 8. So insert to bst of 8, it goes, then again tptr equal to null, root, so it has been again pointing to root. Two new pointers are created, rptr and new node ptr. If root equal to null, root is equal to null, no, false, root is not null, it doesn't go inside the if condition, it checks the while. Now tptr is not equal to null, yes, it is not equal to null, it is true. Now it goes inside the while condition, rptr equal to tptr, both rptr and tptr are pointing to the same node. Okay, now it checks the if condition. Now if we have key as 8 and tptr data is 11, 8 less than 11 is true, 8 less than 11 is true, so 8 has to come to the left side because it is less. So we do tptr equal to tptr left child, so we have to take the pointer to the next node. So we do tptr equal to tptr left child, so it tptr left child when it was here was hash 200. So it tptr is assigned with hash 200. Hash 200 is the address of this node, so it will start pointing to this node. Okay, now again checks the while condition, tptr not equal to null is true because still tptr is pointer is pointing to this proper node. Okay, now again rptr equal to tptr, so rptr has come here, so perfectly right. Then we have key 8 less than tptr data. Tptr data is 9. 8 less than 9 is true. 8 is less than 9. So now we have tptr equal to tptr left child. Tptr left child is null. So when I do tptr equal to tptr left child, it is null. Okay, now when it comes to the while condition, it fails. Tptr not equal to null is false. Comes out of the while, a new node is created, a memory is allocated, new node ptr hash 400 with a garbage value. That key 8 is assigned new node ptr data equal to key 8 is assigned. New node ptr left child is null, new node ptr right child is null. Then again a comparison is there. Key 8 less than rptr data. Key is 8, rptr data is 9. 8 is less than 9, that is true. So we have rptrs, so as it is 8 is less than 9, it should be a left, right? So left child has to be assigned with hash 400 address, that is the node address. So that is what we do here. rptr's left child is assigned with hash 400. So you can see we have successfully assigned, the link is established. Okay, end of the function comes out of the insert function. We have successfully created a binary search tree using insertion. So we have inserted values one by one and created a binary search tree. Then we return from the main function. The time complexity is order of log n to add to the keys to the to this binary search tree. So we have a while loop here which goes through each node and compares, and then we will be adding the node, right? So you have seen that. So it is a time complexity of order of log n. And if you want to trace the code yourself with a click of back and next button, you can see the way I'm explaining it to you. You can explain it to yourself by just clicking back and next button, and you will get a clear understanding of the working of this code. So you'll have a clear mapping in your head. So whenever you want, wherever you want, take out your laptop and start tracing the code, and you just simply revise all the concepts in the computer science, and you feel confident in your job or going for an interview or going for any exams. So you will feel confident. Okay. And if you want the code of this algorithm, you click on code button in the Robominions.in AI interview preparation app. Okay. Yeah. Thank you for watching this video. See you soon. Bye. Signing up, Dhananjai Sharma,
founder of Robominions.in. Don't forget to subscribe to the YouTube channel, share with your friends and family. Visit Robominions.in website, crack your toughest coding questions and tech interviews by downloading latest version of the app, and make your coding easy. Thank you for watching this video. Bye.